Abstract, 3 years after ChatGPT's launch, artificial intelligence has evolved from generating coherent text to functioning as a collaborative workplace partner, capable of autonomous planning, coding, research, and analysis. This article examines the transformation of AI capabilities through the lens of Google's Gemini 3 and similar agentic systems, analyzing their implications for organizational work design, human AI collaboration models, and knowledge work transformation. Drawing on recent demonstrations of AI performing graduate level research, autonomous coding, and multi step project execution, we explore how organizations can effectively integrate these capabilities while maintaining human oversight and strategic direction. The shift from human fixing AI mistakes to human directing AI work represents a fundamental reimagining of knowledge work distribution, requiring new frameworks for task allocation, quality assurance, and capability development. Evidence suggests successful integration depends on treating AI as managed collaborators rather than automated tools, with clear governance structures, iterative feedback mechanisms, and realistic expectations about both capabilities and limitations. In November 2022, OpenAI released ChatGPT to widespread public access. Within days, the model demonstrated an ability that seemed almost magical: coherent, contextually appropriate responses to natural language prompts. A contemporaneous observation captured the moment's significance. I think that this is going to change our world much sooner than we expect, and much more drastically. Rather than automating jobs that are repetitive and dangerous, there is now the prospect that the first jobs that are disrupted by AI will be more analytic, creative, and involve more writing and communication. Malik, 2022. Less than 1100 days later, that prediction appears prescient. But the nature of the transformation has evolved beyond simple task automation to something more nuanced: AI as collaborative partner in complex knowledge work. Recent releases, including Google's Gemini 3, Anthropic's Claude with computer use, and OpenAI's GPT-4o with extended reasoning, represent not merely incremental improvements in language generation, but fundamental shifts in AI's operational role within organizations. The stakes are substantial. Organizations that treat these new capabilities as glorified search engines or writing assistants risk missing strategic opportunities for work redesign and capability enhancement. Conversely, those that overestimate current AI maturity or deploy without appropriate governance face quality, security, and ethical risks. This article examines the current state of advanced AI systems, their demonstrated capabilities and limitations, their organizational implications, and evidence based approaches for effective integration into knowledge work environments. The agentic AI landscape. Defining agentic AI in organizational context. Traditional AI tools operate reactively. A user provides input, the system generates output, and the interaction concludes. Agentic AI systems differ fundamentally in their capacity for autonomous goal pursuit across multiple steps without continuous human direction. Wang et al., 2024. These systems can formulate plans, execute multi-stage tasks, self-correct based on intermediate results, and determine when human input or approval is required. Key distinguishing characteristics include autonomous planning, breaking complex objectives into executable subtasks without step-by-step human specification. Tool use and code execution, interacting with external systems, APIs, and computing environments to accomplish tasks. Iterative refinement, evaluating intermediate outputs and adjusting approach based on results. Context management, maintaining awareness of project state across extended interactions spanning hours or days. Judgment about escalation, determining when tasks require human decision-making versus autonomous execution. In organizational terms, agentic AI represents a shift from automation, replacing human execution of specified tasks, to augmentation, collaborating with humans on ill-defined problems requiring judgment. This distinction matters because it fundamentally changes how organizations should structure work, allocate responsibilities, and develop human capabilities. State of practice, capabilities, and adoption patterns. As of early 2025, several agentic AI systems have reached practical viability for organizational deployment. Google's Gemini 3 demonstrates strong performance on complex reasoning benchmarks, with reported capabilities including multi-step planning, code generation and execution, and autonomous web research. Google DeepMind, 2025. Anthropic's Claude 3.7 Sonnet with computer use can interact directly with desktop applications, execute tasks requiring navigation across multiple software tools, and manage projects through explicit inbox-style task queues. OpenAI's O3 model shows enhanced reasoning on mathematical and logical problems, suggesting continued advancement in systematic thinking capabilities. Adoption patterns reveal interesting organizational dynamics. Early enterprise deployments concentrate in technology forward sectors, software development, financial services, professional services, where knowledge work intensity is high and experimental culture facilitates rapid testing. Brynjolfsson et al., 2023. Common initial use cases include code generation and software development assistance, where AI acts as junior developer under senior engineer guidance. Research synthesis and literature review, where AI aggregates and summarizes large document collections. Data analysis and visualization, where AI generates exploratory analyses and dashboards from raw datasets. Document creation and editing, where AI drafts reports, proposals, and communications for human refinement. However, deployment often occurs in shadow IT patterns, with individual contributors or small teams experimenting outside formal IT governance structures. This creates both opportunity, rapid innovation and learning, and risk, data security, quality inconsistency, and organizational capability fragmentation. Organizational and individual consequences of agentic AI. Organizational performance impacts. The productivity implications of advanced AI systems are becoming quantifiable, though interpretation requires care. Research on GitHub Copilot, an earlier generation coding assistant, found that developers using the tool completed tasks 55% faster than control groups, with quality measures remaining comparable. Peng et al., 2023. More recent studies examining GPT-4 in professional writing tasks showed 40% improvements in task completion time and 18% quality increases as rated by independent evaluators. Noi and Zhang, 2023. These headline numbers, however, mask important nuances. Task-level variation. Productivity gains concentrate in routine generative tasks, initial drafts, boilerplate code, standard analyses, while more complex judgment-intensive work shows smaller improvements. Delacroix et al., 2023, found that consultants using GPT-4 performed 12% faster and produced 40% higher quality output on tasks within the AI's capability frontier, but actually performed worse on tasks requiring expertise beyond the model's training. This suggests AI creates a productivity bifurcation, dramatic acceleration on some work, potential degradation on others. Skill-level interactions, effects vary by worker capability. For below-median performers, AI assistance often produces substantial improvements, effectively raising the performance floor. For top performers, benefits are smaller and sometimes negative, particularly when AI suggestions introduce subtle errors that require expert detection. Brynjolfsson et al., 2023. Organizations must therefore consider how AI affects performance distributions, not just averages. Learning and capability development. A critical organizational question concerns whether AI assistance accelerates or inhibits human skill development. Early evidence is mixed. Delacroix et al., 2023, documented that consultants using AI for idea generation subsequently demonstrated more creative thinking even without AI, suggesting positive skill transfer. Conversely, studies of students using AI for coursework show concerning patterns of capability atrophy when AI becomes a crutch rather than a scaffold. Kasnasai et al., 2023. The aggregate organizational impact depends substantially on how AI integration is designed and managed, not simply whether it is deployed. Individual well-being and knowledge worker impacts. The human experience of working with capable AI systems is evolving and organizationally consequential. Early research on ChatGPT adoption identified several psychological dynamics. Dwivedi et al., 2023. Reduced cognitive load and work stress. For routine tasks, AI assistance can decrease the mental effort required for completion, potentially reducing burnout risk. Consultants in the Delacroix et al. 2023 study reported higher work satisfaction when using AI for tasks they found tedious. Anxiety about competence and job security. Knowledge workers whose core value derives from capabilities AI can replicate often experience threat responses. Professional writers, for example, report concerns about devaluation of their expertise and skills. Kasnasai et al., 2023. These anxieties are not purely psychological. They reflect genuine shifts in labor market value for certain capabilities. Meaning and purpose shifts. Work that feels meaningful often involves overcoming challenges and developing mastery. When AI dramatically reduces challenge levels, some workers report reduced satisfaction even as objective productivity increases. Chowdhury et al., 2023. This paradox, that easier work is not always more satisfying work, has important implications for job design. Skill identity and professional development. Knowledge workers invest years developing expertise. When AI acquires similar capabilities through training rather than learning, it can feel delegitimizing. Junior professionals particularly struggle with questions about which skills to develop when AI capabilities are evolving rapidly. Malik and Malik, 2024. Organizations that ignore these human factors risk undermining the very productivity gains AI promises. Successful integration requires attending to meaning, development pathways, and role clarity alongside technical deployment. Evidence based organizational responses. Structured human AI collaboration frameworks. Rather than ad hoc AI adoption, leading organizations are developing explicit frameworks governing when and how AI participates in work processes. These frameworks typically specify three elements: capability mapping, authority boundaries, and quality assurance mechanisms. Capability mapping involves systematically identifying which tasks AI can reliably perform, which require human judgment, and which benefit from collaboration. Consulting firm BCG developed a Task AI Fit assessment tool that evaluates work activities on dimensions including routineness, data availability, consequence of error, and judgment requirements. Delacroix et al., 2023. Tasks scoring high on routineness and data availability, but low on error consequence, become prime candidates for AI delegation, while high consequence judgment tasks remain human controlled with optional AI support. Microsoft implemented a tiered collaboration model for software development work. AI generates initial code for well specified features, senior engineers review and refine AI output for complex components, and architects make design decisions about system structure, with AI providing analysis but not recommendations. Microsoft, 2024. This preserves human expertise in high leverage decisions while accelerating routine implementation. Authority boundaries define what AI can do autonomously versus what requires human approval. Effective boundaries balance efficiency, minimizing unnecessary approvals, against risk, preventing consequential errors. These boundaries should be explicit, documented, and adjustable as both AI capabilities and organizational trust evolve. Consulting approaches that work. Approval thresholds. AI proceeds autonomously on low risk activities, data cleaning, formatting, routine calculations, but must present plans for approval before executing consequential actions, publishing content, deleting data, making recommendations. Escalation rules. Clear criteria for when AI should pause and request human input, such as encountering unexpected data patterns, facing ambiguous requirements, or identifying potential errors in its own output. Reversibility requirements. Ensuring AI actions can be undone or reviewed, such as version control for AI-generated code or audit trails for AI-conducted analyses. Domain restrictions. Limiting AI access to specific data sets, tools, or systems based on sensitivity and risk profiles. JP Morgan Chase established a governance framework for generative AI that categorizes use cases by risk level and mandates progressively stronger controls as risk increases. JP Morgan Chase, 2024. Low-risk applications like meeting summarization require basic data protection. High-risk applications like client communication require human review of all AI-generated content before external sharing, along with explicit disclosure of AI involvement. Quality assurance mechanisms address the persistent challenge that AI can produce plausible but incorrect outputs. Effective approaches include statistical sampling, and auditing. Rather than reviewing all AI output, systematically sample a defined percentage for human verification, with sampling rates calibrated to observed error frequencies. Dual process verification. Having humans verify AI work through independent analysis rather than simply reviewing AI output, which can anchor human judgment. Comparative benchmarking. Periodically comparing AI performance to human performance on the same tasks to detect capability drift or degradation. Explicit error tracking. Maintaining logs of AI mistakes, their consequences, and their root causes to inform both AI usage guidelines and human oversight focus. Capability building and skill development programs. Organizations cannot simply deploy AI and expect effective utilization. Human capability development is essential, but the relevant skills are not always obvious. Prompt engineering and AI interaction literacy. While early AI usage emphasized prompt engineering, crafting inputs to elicit desired AI outputs, more important is developing broader interaction literacy. This includes understanding AI capabilities and limitations, recognizing hallucination patterns, framing problems appropriately, and iterating effectively. Malik and Malik, 2024. Deloitte developed an internal AI fluency training program that moves beyond tool mechanics to focus on critical evaluation. How to detect when AI is making logical leaps unsupported by data, when it's extrapolating beyond its training domain, and when human judgment should override AI suggestions. Deloitte, 2024. The program uses case studies of AI successes and failures to build pattern recognition. Judgment development in AI augmented contexts. If AI handles routine execution, humans need stronger capabilities in areas AI cannot replicate: strategic thinking, stakeholder management, ethical reasoning, and creative synthesis. Yet these capabilities often develop through practice on routine tasks. Organizations face a development paradox. If AI does all junior work, how do juniors become seniors? Approaches that preserve development pathways. Graduated AI assistants. Junior employees work with limited AI support initially, earning access to more capable AI tools as they demonstrate underlying competency. Rotation between AI augmented and traditional work. Ensuring employees regularly tackle problems without AI assistance to maintain and develop core skills. Explicit judgment training. Creating structured learning experiences focused on decision making, critique, and evaluation rather than execution. Mentorship and apprenticeship intensification. Increasing direct coaching and learning relationships to compensate for reduced learning by doing opportunities. Bain and Company redesigned its analyst training program to front-load conceptual learning and strategic thinking development, using AI to handle analytical execution while preserving human work on problem framing, methodology selection, and insight generation. Bain and Company, 2024. The firm reports that analysts develop strategic capabilities faster than in traditional models, though longitudinal data on ultimate career development is still limited. Change management and adoption support. Technical deployment is necessary but insufficient. Successful AI integration requires addressing the human and organizational dynamics of work transformation. Effective adoption practices include early involvement and co-design, including affected employees in decisions about how AI will be integrated into their workflows, rather than imposing solutions from above. Transparent communication about implications, honestly addressing questions about job security, role changes, and skill requirements rather than minimizing concerns. Phased rollouts with feedback loops, beginning with volunteer early adopters, gathering lessons learned, and iterating before broad deployment. Protected experimentation space, creating contexts where employees can explore AI capabilities and develop proficiency without performance pressure or fear of mistakes. Operating model and governance structures. As AI capabilities expand, organizations are establishing new governance structures to manage deployment, ensure quality, and mitigate risks. AI councils and oversight committees. Many organizations have created cross-functional bodies responsible for AI strategy and governance. IBM, for example, established an AI ethics board comprising technical leaders, legal counsel, and business unit representatives who review proposed AI applications for alignment with ethical principles and risk thresholds. IBM 2023. The board maintains a living repository of approved and prohibited use cases, reducing redundant reviews while ensuring consistency. Role clarity and accountability. When AI contributes to work products, clear accountability becomes essential. Who is responsible when AI assisted analysis contains errors? Who owns decisions when AI provides recommendations? Governance approaches that provide clarity. Human accountability for AI assisted work. The human who directs AI work remains accountable for its quality and appropriateness, regardless of AI's contribution level. Documentation requirements. Maintaining records of AI involvement in consequential work products, including what AI did, what humans reviewed, and what approvals occurred. Competency requirements. Only allowing individuals with demonstrated domain expertise to use AI for work in that domain, preventing abdication of judgment to AI. Escalation responsibilities. Clear specification of when AI related concerns should be elevated to management or specialized review. Goldman Sachs implemented a policy that any client facing material incorporating AI generated content must be reviewed by a senior professional with subject matter expertise, who formally approves the work and assumes responsibility for its accuracy. Goldman Sachs 2024. This preserves accountability while allowing productivity benefits. Risk management and controls. Agentic AI systems that can execute code, access data, and interact with external systems introduce new risk vectors requiring specialized controls. Control mechanisms include sandboxed environments, running AI in isolated computing environments with limited access to production systems and sensitive data during initial deployment. Access restrictions, limiting which data, systems, and tools AI can interact with based on use case risk profiles and demonstrated reliability. Monitoring and anomaly detection, implementing automated systems that flag unusual AI behavior patterns for human review. Version control and rollback capabilities, maintaining the ability to quickly revert to pre-AI processes if issues emerge. Regular security assessments, periodically evaluating AI systems for vulnerabilities, prompt injection risks, and potential misuse vectors. Financial and resource allocation models. AI integration requires thoughtful resource allocation decisions, including direct costs, subscriptions, compute, indirect costs, training, governance overhead, and opportunity costs, human time spent managing AI. Cost benefit analysis frameworks. Organizations are developing models to evaluate AI investment returns, though measurement challenges persist. Direct productivity gains are relatively straightforward to quantify. Hours saved, output increased. Harder to measure are quality improvements, innovation acceleration, and capability development effects. Unilever developed a financial model for AI investments that includes quantified productivity benefits, estimated quality improvement value through error reduction and enhanced output, and allocated costs for governance, training, and tool subscriptions. Unilever 2024. The model revealed that governance and training costs often equal or exceed direct tool costs, informing budget allocation. Investment sequencing. Given resource constraints, organizations must prioritize which AI capabilities to deploy and which workflows to redesign first. Effective sequencing strategies. High volume, moderate complexity tasks first, starting with work that is frequent enough to generate substantial time savings, but not so complex that AI reliability is uncertain. Low stakes applications before high stakes, building organizational confidence and learning with applications where errors are readily detectable and minimally consequential. Bottleneck relief, targeting processes that constrain organizational throughput, even if absolute time savings are modest. Early adopter populations, beginning with teams that are enthusiastic and capable of providing sophisticated feedback to inform broader rollout. Building long-term AI integration capabilities. Continuous learning and adaptation systems. AI capabilities evolve rapidly. What requires human expertise today may be AI tractable tomorrow. Organizations need systems for continuously updating their understanding of AI capabilities and adjusting work allocation accordingly. Capability monitoring, regular assessment of AI performance on organizational tasks, tracking both improvements and degradations over time. This requires baseline establishment, measuring current AI performance, periodic reassessment, testing new AI versions on the same tasks, and comparative analysis, determining whether capability changes warrant work redesign. Accenture established an AI Capability Observatory that systematically tests major AI model releases on a standardized set of tasks representative of client work. Accenture, 2024. When new models demonstrate substantial improvements on specific task categories, the observatory triggers reviews of related workflows to determine whether task allocation should shift. Learning loops, mechanisms for capturing lessons from AI usage and propagating them across the organization. This includes both positive lessons, effective prompting strategies, successful use cases, and negative lessons, failure modes, inappropriate applications. Effective learning mechanisms, communities of practice, forums where AI users share experiences, techniques, and insights across organizational boundaries. Structured retrospectives, periodic reviews of AI augmented projects to identify what worked, what didn't, and why. Knowledge repositories, centralized collections of effective prompts, use cases, and guidelines that grow and evolve with organizational experience. Expert networks, identifying and connecting individuals who develop deep AI interaction expertise to serve as resources for others. Feedback to AI development. Organizations with sufficient scale and sophistication can influence AI development by providing feedback to vendors about capability needs, failure modes, and feature requests. This creates a virtuous cycle where AI systems become better aligned with organizational requirements. Human AI partnership models and work design. Rather than simply asking, what can AI do? Forward-looking organizations are asking, how should humans and AI collaborate on this work? This reframes AI from a replacement technology to a collaboration technology, opening different design possibilities. Comparative advantage-based allocation. Economic theory suggests optimal task allocation based on comparative rather than absolute advantage. Ricardo, 1817. Acemoglu and Restrepo, 2019. Even if AI becomes better than humans at task X, humans should still perform X if the human performance advantage over AI is greater for X than for alternative task Y. This principle suggests nuanced task allocation that considers the full portfolio of work, not task-by-task automation decisions. Organizations applying this lens might assign AI to tasks it performs only moderately well, if doing so frees humans for tasks where human advantage is overwhelming. Boston Consulting Group research found that having AI handle moderately complex analysis allowed consultants to spend more time on client relationship building and strategic framing, where human skills remain strongly dominant, producing better overall project outcomes than having consultants do all analysis themselves. BCG, 2023. Complementarity-focused design. Some tasks benefit from human-AI collaboration where each contributes distinct strengths. AI might generate comprehensive options while humans evaluate and select. AI might process large datasets while humans interpret findings in business context. AI might produce initial drafts while humans refine for audience and purpose. Collaborative patterns that leverage complementarity. AI breadth, human depth. AI explores wide solution spaces and generates diverse options. Humans provide deep evaluation and contextual refinement. AI speed, human judgment. AI rapidly produces initial outputs. Humans apply slower, more deliberative judgment to validate and enhance. AI consistency, human adaptation. AI maintains adherence to standards and procedures. Humans flexibly adapt to unusual circumstances and exceptions. AI explicitness, human tacitness. AI works from documented knowledge and explicit patterns. Humans apply experience-based intuition and tacit understanding. Role evolution and identity. As AI capabilities grow, human roles must evolve beyond task-based definitions toward value-based definitions. Rather than data analyst, task-focused, roles might become insight generator or decision support partner, value-focused. This shift preserves purpose and meaning while accommodating technological change. Salesforce redesigned its sales operations roles from task-oriented job descriptions to outcome-oriented definitions. Salesforce, 2024. Rather than prepare sales reports, task that AI can handle, roles focus on enable sales team success through data-informed insights, outcome that may involve AI, but emphasizes human judgment and stakeholder understanding. This framing allows AI integration without role elimination. Organizational learning and knowledge management. AI integration interacts complexly with organizational knowledge. On one hand, AI can democratize access to organizational knowledge by making it queryable and synthesizable. On the other hand, AI may reduce knowledge creation if human learning opportunities contract. Knowledge capture and codification. AI performs best when organizational knowledge is explicit, documented, and accessible. This creates incentives for knowledge management investments that benefit both AI systems and human workers. Siemens implemented a comprehensive knowledge management initiative alongside AI deployment, systematically documenting engineering processes, decision criteria, and design rationales that previously existed only in expert heads. Siemens, 2024. This documentation both enabled more effective AI assistance and preserved critical knowledge against workforce turnover. Preserving knowledge creation. Even as AI handles more execution, organizations must maintain processes through which humans develop expertise and generate new knowledge. This may require deliberately preserving work that is technically AI automatable but developmentally valuable. Approaches for balancing automation and development. Developmental task preservation. Maintaining some manual work specifically for learning purposes, even when AI could handle it more efficiently. Rotation through foundational work. Ensuring employees periodically engage with fundamental tasks to maintain understanding of first principles. Knowledge creation incentives. Explicitly valuing and rewarding human generated insights, innovations, and expertise development alongside productivity metrics. AI as learning accelerator. Using AI to enhance learning efficiency, personalized explanations, practice problem generation, rather than replace learning entirely. Conclusion. The transformation from AI as chatbot novelty to AI as collaborative partner represents one of the fastest technological shifts in modern organizational history. In under 3 years, we have moved from marveling at coherent paragraph generation to debating statistical methodology with AI research assistants. This velocity shows no signs of abating. For organizations, the imperative is clear but challenging. Integrate AI capabilities rapidly enough to capture competitive advantages while thoughtfully enough to preserve human development, maintain quality, and manage risks. Evidence suggests several critical success factors. Treat AI as collaborator, not tool. The most effective implementations design human AI partnerships rather than simply deploying AI to automate tasks. This requires explicit frameworks for task allocation, authority boundaries, and quality assurance. Invest in human capabilities. AI integration does not reduce the importance of human skill development. It changes which skills matter. Organizations must evolve training, mentorship, and career development systems to emphasize judgment, strategic thinking, and AI interaction literacy. Build governance structures. Ad hoc AI adoption creates risks and missed opportunities. Effective governance, through AI councils, clear accountability models, and robust controls, enables confident scaling. Maintain learning systems. AI capabilities evolve rapidly. Organizations need mechanisms for continuously monitoring AI performance, capturing lessons from usage, and adapting work design accordingly. Preserve meaning and purpose. Productivity gains mean little if knowledge workers feel devalued or purposeless. Successful integration attends to psychological needs for mastery, growth, and meaningful contribution. The era of AI as digital coworker is beginning, not ending. Current systems still require human direction, judgment, and oversight. But the trend is unmistakable. AI is moving from executor of specified tasks to participant in complex knowledge work. Organizations that learn to collaborate effectively with these new partners, balancing delegation with development, efficiency with expertise preservation, automation with augmentation, will define competitive advantage in the years ahead. The question is no longer whether AI will transform knowledge work, but how organizations will shape that transformation to preserve and enhance human capability while capturing technological potential. The answer will determine not just organizational success, but the future nature of work itself.